So there we go. We're now on record. And I'll flick it over to James. As you can tell by the cover slide, this is about help with the internal.
Cool.
James, there you go, my friend.
Thanks for the introduction.
Some people like to climb mountains.
When I saw this clip,
I like to
I just
build
couldn't help
planes
to put it in.
the air.
Not sure how many people have seen it. I'm sure we could probably all appreciate that NCA Level 1's been a bit of a journey for us this year.
Sometimes the temperature up at altitude will reach 60 below. It's brisk.
Sometimes it feels a little bit like this if we're building the plane as we're flying.
Owls. These people back here, that's why I come to work. That's why I build airplanes. I
can let you watch that in your own time. I'll make a start and then I'll talk through what we're going to do this evening. So tēnā koutou, tēnei ahi hahi, ko James Harris tōku ingoa. Maro mātauranga tātā riki pūtai au, ko Middleton Grange Otutahi, no mai, haere mai. Cool. So a little bit of a tongue-in-cheek kind of video about building a plane in the air, as many of us have probably been feeling a little bit vague about what we've been doing. So tonight I've been asked to speak about developing a teaching and learning program for PESS 1.2. My goal was kind of the next 30 minutes to hopefully give us some clarity around where we can fly and how we can land this kind of metaphorical PESS 1.2 plane. Many of us are experienced flight instructors. We know teaching and learning reasonably well. We know content, we have clarity around a whole bunch of things, but if we don't know where the plane needs to land, it increases our stress. And I think hopefully by the end of today, I can give us a little bit of, an idea of what the runway could look like and potential places that we could take our konga. You'll notice that, so there's a bit.ly link here, PESS, all capitals 1.2, and on that link, there's a copy of this PowerPoint. There's a copy of a teacher scheme, there's a copy of our experiments, and a link to a whole bunch of other useful resources for PESS 1.2. So feel free to go and check that out. So basically everything digitally that we do tonight is going to be found there. So our agenda is to go through different potential contexts that could be used to assess PESS 1.2 and discuss their pros and cons, suitability and plausibility. My goal is to hopefully give us some clarity about the experimental contexts in which assessment could take place, to really know what the runway looks like, but more than that, to hopefully inspire you of what great teaching and learning could look like. Many of the experiments I show could be used as summative assessment, but equally they could be used as part of a dynamic teaching and learning program. I've tried hard to provide contexts for people who have very little experimental equipment and knowledge all the way through the continuum. If you've logged into the NZIP secure site, you would have seen a bunch of suggested tasks and experimental contexts there. I'm not going to be showing those tonight. You can find them in the link, but you do have to log in with your NZIP credentials. But I will be showing you some videos of different experiments, things that are tried and tested that work. I'll suggest another couple of experiments, potential assessment, quality experiments that aren't on the NZIP site. Two of them I think are so good, I almost wish I'd run them for my own summative. And then I'll explain a little bit of our journey, our successes, our failures. Hopefully you can learn from some of them. And there's some Q&A at the end for those who are there. Really quickly, why are you a teacher? I hope and suspect the number one reason you don't give is because you want to make your pupils do assessments. But it's so easy when we're in this time of change, when there's so much assessment stuff that can really colour our vision. And so my question is, what is really driving our teaching and learning programs? Is it our archon? Is it our pedagogy? Is it stuff that we deem to be good knowledge and skills? I hope it's all of those, as opposed to just what's the least thing I need to do to get these kids through this test? Or I get this attention. I'm a curriculum leader. We have to know how to, have good results and assess our students well, but we also want really good teaching and learning. And so tonight, my goal is to take us through that journey. So probably like a bunch of you logged onto the nca.education website and you saw these tasks. So this Walker board order task, that really captivated our staff. We're like, oh yeah, let's have a go at that. We came up with this title, Gutter Boat Regatta. And we're like, well, there's heaps of things we can change. We can change what the bow of the boat looks like, its mass, its surface, the area. Okay, well, let's have a go at that. okay, well, we need a fan. So we went on AliExpress. I'd highly recommend these fans. Anything that's above 4 amps and 2-wire, 12 volts, amazing. But this particular one's really, really good. And we put a little bit of a funnel on it, and that drastically increases the force. And then we tried a whole bunch of stuff. We tried wood. Wood's not very good. It sinks. $2 shop boats were a bit useless. But this high density polyurethane worked quite well. So here's an example of that. And we were looking at that, and when we looked at the pros and cons, we've got electronics next to water, we've got potential of spilling water on the floor, you need to buy a whole bunch of equipment. If you've got a small class or whatever, yeah, it could work, but yeah, probably not really suitable to roll out across big groups. So then we came across this idea of, well, why don't we do a land yacht? This is something we've done in our Year 10 program, where the kids have made their own land yacht, and they've had to discuss useful and unuseful friction. We're like, well, we could apply that to our Year 11 context, but then we didn't have lots of really good carts. So the cart in that video is quite expensive, and these other carts over here don't work. And so then, well, okay, what do we do? Well, we tried some ball bearings. They were a disaster as well. Then I went on to Amazon, and I found these Pinewood Derby cars. And so this is what Scouts of America have used for 30 years. They do a whole bunch of racing with them, and these are fantastic. I don't know where these carts have been my whole working life, but they are just incredible. And you get 12 of them for just over $100. They come with the grooves and the wood, and the axles just push into those little grooves. If you chuck some Aerodite glue on them so they don't pop out, they go nice and straight. They can run over a 1 meter ruler really easily. We drilled a hole in the top so you could put your 50-gram slotted masses in them. Yeah, we found these to be really, really good. And so maybe 4 or 5 of the experiments that I talk about today use that. And yeah, there's the 50-gram slotted masses. Cool. And so this is the experiment we actually did for our formative. So we had a 12-volt fan, and it's adjustable from 6 to 12 volts, blowing a land yacht. So that can easily do, I don't know, 2.5, 3 meters with a well-designed sail. And there's lots of things you could change: the mass, the wind speed, the sail area, the sail angle. So we ran that as our formative, and it worked really, really well. And it also worked
10 watts for the
ticket buttons. So most schools don't have motion sensors.
That's still moving. Getting a reasonable display of top. That's still reasonable.
And it can also be done using a stopwatch. So we also then reflected on, well, what could we do? What else could be another example? So this balloon propulsion example came up. So we went on Temu. We bought one of these. And yeah,
so 50 pump.
It's good. It's interesting. A great teaching and learning point. Talking about Newton's laws. Talking about friction. Talking about there's a whole range of things you could talk about. This one, I probably wouldn't recommend it as a formative or a summative. Does work very well with ticker tape.
50 pump tape. Here we go.
Doesn't work with motion sensors, so it's not a flat surface. But yeah, it is what it is.
We have a pump to just over 3 psi.
This is an air rocket. So it's got a little hole in the end, and the hole has to be about the same diameter as the ball needle pump valve. That works really well. A 5 psi change in pressure makes a huge difference to the force and the distance and its acceleration. Heaps of really great learning there, but to roll that out as something you do across entire cohorts is probably cost prohibitive, but a really neat thing. Essentially, it's a 1.5 litre bottle strapped to one of these derby carts, going across some rollers. That'd easily do 5 meters at 30 or 40 psi. Bruce Uni's got this amazing launch mechanism, so if that's something you wanted to look at, it requires a little bit of building some stuff, but that's quite a cool task. This one here is probably one of my favorite. This probably a really simple one. It doesn't require a whole lot of gear. Essentially, it's a mass falling over a pulley, dragging a cart, and it doesn't really
we
matter
have 10 grams
what
suspended
type
from
of
a
cart you've
string.
got. So 10 grams will easily pull these carts. Even if you don't
40
have
grams.
carts, it'll pull a block of wood. There's lots of things that you can change. You can change the mass of the cart. You can change the mass that's falling. You can change the surface that it's on. You can change the incline of the bench. And in this case, we've got it balanced. So traveling at a constant speed when the forces are balanced. And so there's heaps of teaching and learning you can do in this one. We did this as partway through our program. We found it to be really, really good. Yeah, really, really helpful activity to do. I think it would make a great summative activity. The physics is really simple and obvious. It works. So this is one of my probably favorite. There's some technical stuff there which is helpful to think through, but some of that's beyond year 11. A lot of us would have done rolling the ball down a ramp, some nice easy stopwatch stuff, measuring the speed across the desk, and then to work out the acceleration down the ramp. There's a great page in SciPad on that. This one is another one that works pretty well. This is what we're actually using for our summative assessment. So the idea of a runaway truck, so these carts are having to be stopped by something, and a whole range of things. The height of the ramp, or how far down up the ramp goes, or what's it. Yep, that's nice and simple. Works.
You are getting.
It also works with
a reasonable set of dots. So you're seeing
with ticker tape, so you get beautiful dots of ticker tape. You probably actually get almost better data with a ticker timer than you do with the motion sensor if the angle's too high, because the motion sensor can only see in a straight line. Yeah. This next one's probably one of my favorites. This one is not on the NZIP site. These things are amazing. So here's in the video. There's so many things you can change, and it goes for ages.
Parallel.
So free number 19 rubber bands.
Warehouse stationary. Wherever, so that's 2 rotations.
So with 2 rotations and 3 rubber bands, like it smashes out 7 meters.
Getting the full 7 meters at that.
So if you don't have
5 rotations of the
any gear, all you've got is a stopwatch and a tape measure, this is fantastic.
So
you get all the data you need. It's nice, and like the timing is brilliant.
Still with 5 rotations.
And there's so many things you can change. It will pull ticker tape.
Ticker tape with the ticker tape free to move on the floor.
The ticker tape's free.
Ticker tape on a roll. You notice a big difference with the
roll. On a roll, and you'll notice on the roll the wheel spin.
With a wheel spin, ticker tape on a roll doesn't really work. So now back to free and parallel with a sail, or looking at the different aerodynamic factors. So you could change the surface area of the sail.
The big sail makes it not go as far. There's heaps of things to change there.
I'm changing the number of rubber bands, just having 1 rubber band all by itself rather than having 3 in parallel. So the number of rubber bands makes a big difference.
And you can buy these kits on Amazon.
So you go through.
You can build your own using like a wood saw.
2 rubber bands in series.
Sure, you could 3D print them as well.
3 rubber bands in series. So again, that's size 19.
Series and parallel. Ultimately, you're just changing spring constant, but at year 11 level, that's where you count them as different variables.
There's some really good written instructions at instructables.com. There's also some really good video instructions on YouTube. So there are things that you could change for this investigation for PESS 1.2 would be the number of rubber bands, the type of rubber band, the number of rotations of the wheel, the mass of the cart, and the surface area of the sail that the air is blowing against. All of those make a reasonable difference. And the key part of the rubber band car is this green little zip tie where the rubber band hooks over and then you can wind it up. And then when it unwinds, it detaches from the axle to allow it to freely spin. If it was me, I would build the cars ahead of time and just give them to the kids and let them play with the rubber bands. Hope that was helpful.
So this is a car my 8-year-old at home made with me over the Easter weekend. we just got 100 mil. So called, I want to say drill, but I suppose it is a drill bit that cut a hole. We cut out an MDF. Yeah, and it worked really well. It didn't work quite as well as the plastic ones. I'd recommend getting little wheels and big wheels, little wheels on the front and big wheels on the back. Yeah, a great prac. This is another prac that's not on the NZIP site.
Back about 8 centimetres.
Little shooting carts.
2 rubber bands pulled back about 7 centimetres. Now we're over 3 metres. Now we're 3 size 19 rubber bands pulled back 8 centimetres.
It goes
3
really
rubber bands
well.
pulled back 4 centimetres.
So
So we see pullback distance makes a big difference. So 350 grams of 3 rubber bands.
mass makes a big difference.
So mass makes a big difference. So this is just 2 pieces of wood with some rubber bands in it clamped to the bench. So 3 number 19 rubber bands with a different trolley.
And even if you don't have,
Works. But basically any trolley that rolls.
you have some smooth wood.
So this
Push
is
on
another
your
setup.
bench.
And so another setup using retort stands clamped to a bench. And easily cover 1.8 metres.
So that's a really good one. And another one, well, so a context for that might be a roller coaster or shooting a plane up into space or whatever. So there's a range of contexts that could be true for. Here's a little slingshot car. And again, there's heaps of things that we could
So here's the
change.
pen just sellotaped onto a ruler, and then the wooden ruler as a guide. A rubber band, hook it over the front of the pen.
So again, it's the same
And that-
derby car, this time just with a little hook on the
About
front.
10 centimetre pullback. Rubber band. And then if we pull it back further, maybe like 20 centimetre pullback. Drastically faster. And then if we add some mass, so 350 grams.
All the same things as the previous one, really.
Slower, and then if we change the amount of mass, we take 150 grams off. And do it again.
Yeah, I almost wish I'd done this as my summative because it's just so clear and easy and simple.
And then we can increase the number of springs, so we can add.
That you can watch that in your own time. I think some of my thinking when I first looked at this standard was initially had buoyancy in it. It had no pressure, and we had the energy external, and so I kind of assumed we couldn't do energy. But actually, there's no reason why we can't do energy, and actually, there's a whole bunch of energy pracs which are really, really helpful. So I think I might just take us through what we've been doing in terms of our program. And so this here is an O-rings playing activity. This is how we actually started our unit. This is thanks to Stephen Anderson, who used to work with us. He showed us this. There's so many things you can change with this. This is like an open, multi-variable thing that you can try and optimize, changing the width or radius of the front and rear ring, and the length of the stick, the mass, the number of rings. There's so many things that change, and there's a cool video of this being done in space. To compare and contrast what the effects are on Earth. And so we did this as our WOW lesson, as our introduction, to try and figure out different types of variables and what's an independent, dependent, and what's a fair test, and all those types of things. And there's lots of instructions and guides to how you do O-ring planes.
And so the purpose of that is when we rotate
These are
it,
oil-filled
and then you
pipes.
can click start on the stopwatch as soon as it goes past that first
We'll be
line, and then
inside.
you can time for the first 0.2 meters, then 0.4 meters, then 0.6.
This is just some good stopwatch stuff. How do you
And in this case, you can
measure
almost get to 1
speed?
meter.
What's terminal velocity? Why is that?
Got a spring that we're pushing again.
I'm sure we've all got
And it actually
all that cars that
turns all of those wheels.
they're quite good in that you can push them down and they're quite fast, and you can pull them back and they go. So there's a whole bunch of energy change stuff. There's a whole bunch of unbalanced force, when's it accelerating, all those types of things. And they're pretty cheap, $3.70 on Temu, free shipping. I'm not getting any money from suggesting Temu purchases, but trying to provide different contexts in which yeah, the kids love these actually, and they love seeing the little mice or whatever they are, cats moving them inside. Something that I'm sure we all do. Yeah, sorry, all these contexts are in a mechanics context. Part of the thinking behind that is that at Middleton, got, I don't know, 230-ish pupils in year 11, at least 65% of them continue into level 2 sciences. We wanted our level 1s to be really well prepared for level 2 physics next year. Mechanics seemed like a no-brainer to be doing, and so that's why all our contexts are in a mechanics context. So I'm imagining this is something that we all do. Kids go for a walk, jog, run over 10 meters or 5 meters, and we measure their speed. We've had motion sensors. Well, when I started, we had an old one that plugged in. It was pretty touch and go. It was a bit average. Maybe 4 years ago, we bought one of these Vernier Go Direct ones, and we've done walk the line, and we've shared that, one sensor per class, and that worked okay. And then maybe a year ago, we got up to 4 sensors and now up to a class set. I'd highly recommend them. I appreciate that's probably outside of some of your budgets, but I think if you begged your SLT, and if you're going to do some of the activities that I've been going through, I'd highly recommend these. They Bluetooth directly into the kids' devices. They give pretty clean data. Yeah, they used to be really difficult to use, and now they're reasonably idiot-proof. And so we get our kids to do a little circus activity where they have to go and make a whole bunch of graphs and predict stuff, and difficult to do if you don't have that technology. This is quite fun. Another Temu purchase. Essentially, this is a little helicopter that just hovers. So we do a whole bunch of force stuff around that. So but when it's hovering, what are the forces? And then you get a piece of paper and you can waft it across the room and what's forces there. And the kids really seem to
11 kilos, if we let them go.
Yeah, this is a random bit of kit that we made. So this is 2 wheels off a mountain buggy, off a pushchair, front wheel and the back wheel hooked onto a piece of wood, and we can just drop some masses.
11 kilos, we let them go.
There's lots of things you can do. So we can often accelerate carts, and that's one thing, but to do it on a human scale, change the number of people being pulled, or have a bigger person versus a smaller person, or have more suspended mass, or just some really cool equals MA kind of links. Yeah, it's interesting. As years go on, the kids are becoming more reluctant. Well, you get different sets of kids, but maybe 5 years ago, they'd be super keen to do this, and now they're maybe a little bit less. Yeah, I'm sure we've all used PhET. This particular simulation, if we're doing, yeah, so this is a great simulation, net force versus applied force, linked to speed, linked to acceleration, and then you can add friction. Yeah, I think there's lots of really powerful learning in that particular animation. There's this energy animation as well, which is quite good, looking at EP to EK and then how some of it's transferred into other forms. These are quite fun. So a little training shoot where we talk about drag, and the pupils go out and they run against each other with the shoot on and the shoot off, and they talk about, they draw a free body force diagram and link having increased drag means less net force and then less acceleration and what have you. These are quite fun in a similar kind of context. You can drop these off, I don't know, off near the roof or off the balcony or whatever, and discuss forces with them. This is a context, dropping these tones. There's lots of things you can change. The time to measure it's pretty short. There are real differences in that, and yeah, I was showing this to my son actually, and the next day he's like, "Oh, Dad, I made you a different version." And so this is an example of the same thing. So you could change the balloon, identical balloons, and change the mass attached, or you could change the radius of the balloon. A bit fiddly, the timing's not amazing, but if you were to do this one as as a summative, then this one as a formative could be good. So that is quite beginners in some little messes. So these are really cool. So essentially they're a rubber band and a blade onto some popsicle sticks. I was impressed with how far these go. You could probably do that as a formative activity. There's a few things you could change. So you can get these propellers, and there's little helicopters ones as well. Yeah, I don't know. I did this one with my class. I don't know. I thought it could have been worthy of an assessment, but I don't think it really is. They're cool, but they are what they are. Maybe quite interesting at a year 13 level, looking at conservation of angular momentum or something like that, and why you need the thin. But at year 11 level, yeah, it's cool if you're doing some energy change stuff, but probably not assessment worthy. Cool. So maybe it's worth looking at some of the resources that are there, and then if people have any questions, I can have a crack at them. So on that bit.ly PESS12 site, you'll see that there's access to a OneNote, which is inside of the NZIP site. And there's a scheme, there's a booklet, and there's a whole bunch of experiments and resources. So maybe if I go there and just talk for a little bit of what's there. So we start off with our O-ring plane and brainstorming, what is a fair test, what are our variables. Then we did some stuff on fair testing and collecting data. Then we did what is speed, velocity resistance over time, measuring speed of pullback cars, walking. Then we did some distance time calculation stuff. So them actually drawing distance time graphs by hand, describing the motion, a bunch of pages out of SciPad, out of the booklet connected to that. Then we did acceleration, looking at gradients of speed time graphs and calculating area and all that kind of stuff. Then looking at force, net force, unbalanced forces, drawing free body force diagrams, F equals ma. We actually probably ran out of time, and so we ended up not focusing much on mass, weight, and gravity, which something's got to go somewhere. We probably found we needed another 4 more periods really to do justice. So we had 33 periods for most of our classes this term, and I think 38 would be ideal. We looked at Newton's laws, although we didn't do many of those pracs. We did a 4-period formative, gave some feedback. Then we went and did some energy, EP equals EK. We didn't look at energy stewardship. And we didn't cover pressure, buoyancy, work, or power. And so, yeah, if we had 37 periods in reality, we probably could have got there, but we didn't. And we've given our pupils 5 periods in class to do the summative, and we've allowed it to be entirely open book. Although what we found was that how pupils interpreted open book in the formative was quite different to how we thought open book would be interpreted, and that they thought it was okay to share reports with each other and read them and critique them and copy bits and whatever. It's not what we'd quite interpreted as open book, and so we've had to re-clarify what open book meant. There's a student booklet, and I can let you look through this in your own time. Some student learning outcomes, variables, fair testing, there's the O-rings. A lot of it follows what I've already spoken through. I've included some planning that we've had and discussions that we've had as team meetings that may be helpful. The student learning outcomes that were made by the ministry, so they send to IP, are sitting there, a copy of the achievement standards sitting there. All the experiments that I've gone through that are in the scheme are also there. There's a kind of order of what we've done it in. Yeah, so there's a bunch of stuff there. I might pause and see if people have some questions or some things that people might want some clarity on, whatever.
All right. Well, thanks, James. Let's see. A few questions have popped up. First off, somebody was asking, When did you run this assessment? Like, is it this term? And also, were you a pilot school, or is this all totally new this year for you?
Sure. Yep. So actually, 8 of our classes started today for our summative. So we haven't quite done that. So we're running it this term. We're not a pilot school, so everything that we've come up with is basically read off the website with a little bit of a discussion with some people at NZIP. Yeah. So we semi-marked or provided some formative feedback on the formative assessment, which is quite helpful for us as staff to kind of know where we'd got things right and where we got things maybe not so tight.
Yeah.
Yeah.
Yeah, I noticed that you had a gap between the formative and the summative to give that feedback to the kids. And you say you have 8 classes that are currently involved in this.
Yeah, we've got 9,
Okay.
so 225 kids or whatever.
That's
so fully mixed ability.
Yeah.
7 teachers. Yeah, like it's pretty full on.
And do you run 4 or 5 periods a day, or sorry, 4 or 5 periods a week?
Yeah, so we see them 4 times a week. Yeah.
Okay.
Yeah.
So that's one of the logistical questions that popped up. Somebody was really impressed with the good old Pinewood Derby cars. I haven't seen those since I was a kid. But yeah, and they were easy to get, you said.
Yep, 2 weeks on Amazon. If you buy the right amount of money, they came with free shipping. They take, I don't know, half an hour to put a class set together. You got to get the spacing between the wheels and the wood right.
Yes, friction's the magic thing.
If they're too far out or they're too close, it doesn't work. So you got to get that spacing perfect. So maybe put a piece of paper or 2 pieces of paper in there to get that right, and then they run over those 1 meter rulers really well.
Yeah, perfect fitting. Somebody's asking if you could give some information on the feedback to the formative assessment. Like, how did the kids go? And you mentioned their interpretation of open book that you had to screw back down into what a adult would interpret that. Are there any other things that really surfaced that you weren't expecting during the formative?
Yeah. So our pupils used motion sensors, and so they had to have software installed on the computers. There were some technical difficulties around that we've been doing that for the entire term, but there's still 8 kids that hadn't installed the software. So there's those kind of logistical things, or for 2 kids they hadn't updated Windows and so the sensor didn't connect, or those things kind of threw us a little bit. In terms of how the assessment ran, not everyone submitted their formative report. So if they didn't hand it in, they didn't get feedback. And so that'll come back and bite them for the summative, but we've all got those kids. We chose not to push them too much. Some kids found it a little bit overwhelming, like what was actually required. And so we probably had a number of conversations around that as staff around, what is the minimum required for excellence? And so I went through my class and said, actually, I think this here is what an excellence report looks like. It's got this, 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 and this. And I think
did you give them examples or just talk through the short list?
Yeah, so I gave that to teaching staff, and teaching staff, essentially they were pupils' work, or aspects of pupils' work, exemplars. They were allowed to be read on the data projector, but they weren't given to kids, because essentially that's what the kids needed to regurgitate. If whatever they've done in their formative, the summative is basically the same, right? And so you needed to have a degree of authenticity there.
Okay, so they were viewed. What was the basic boundary conditions between achieved and merit? Like, how did the kids get in their headset? Here's an achieved, here's a merit, here's an excellence. Because you mentioned the excellence thing that you just went through.
Yeah.
What the passing threshold or the merit threshold?
Sure. So we didn't spend a lot of time saying this is what absolute minimum is for achieved. We kind of said this is what aspirational excellence looks like. And if you're attempting to be at aspirational excellence, then you're going to easily be at achieved merit. We defined, so a lot of kids didn't do 4 data points, and so that knocked them from our marking grid to not achieved. And so that might be something worth having a conversation about. I'm not necessarily saying I'm right, but on the NZIP exemplar generic student marking grid, it does say 4 data points.
So that was a flavor of your feedback to the kid saying you're going to need more data points in the form of the summative assessment.
Yeah, so they needed to have 2 graphs. They needed to have independent, versus dependent for one investigation and another one for the other investigation. And they needed to state the relationship that each of those said,
Gotcha.
and have some 2 sentences of some physics there, and that was kind of achieved.
Mhm.
And then excellence was the key distinguisher for excellence, was connecting both of those dependent independent graphs together and saying overall, therefore, so for the blow cart land yacht, they had to say we had to decrease mass and increase wind speed to maximize the Emirates land yacht or whatever. So they had to link it back to context as well, not just physics. And yeah, there's a nuance there, and I think a good number of pupils got there and a good number didn't. Like, yeah.
No, it's a massive task. How many other standards are these kids doing in their science course? This is one of them for term 1, but
yeah, so we're a reasonably academic school in that kind of sense, in that most of our pupils would continue into level 2 in some sense. And as a team deciding on what level 1 standards to offer, it was that we really wanted a term on each of the sciences. So one on chem, phys, and bio. And so we were meant to start with chem, but we weren't quite confident enough. And so we started with physics this year. We're doing the chem bio 1.2, and then we're doing the genetics in term 3. So they're doing 3 standards. Yeah. I was probably surprised about how long this took. There's a lot of skills in here. Like, it's kind of science theory. It's kind of physics 1.1-y. It's the mechanics standard, but then it's not just a 1-hour test. It's this open book investigation-y. Yeah, there's a lot there, and being open book, I don't think really helps that much. The kids.
What did the kids think? Did the kids think open book helped? Well, especially once they learned what you thought open book was.
Yeah, they loved it. Like, the sense of I can go home and spend time with it in my own time. We have a reasonable number of kids who have special learning conditions stuff, and so they needed to have access to extra time or reader writers or whatever. And so took a lot of stress off us. It meant we didn't have to have everything locked down. And like, I honestly, and one of the conditions where they weren't allowed to use Chat GPT or any other AI tools. How we police that, I don't know. Yeah, I don't think it really gives them a whole lot. And they've got to be able to write in their own words. I don't know.
My next question was about what are your plans after the summative is done for authenticity checking? Is it sort of the teacher using their gut? Is it as well as a few conversations as needed?
Yeah, we haven't quite got there, but if a staff member perceives that it's not the student's work, then I suppose there's a conversation there. We wanted to discuss this idea that we'd sample 10 or 20% of the cohort to have to give a verbal dissertation or a defense of their work to prove that it was their own. But I suppose that depends on how much we think these kids are cheating. We're running the assessment with inside of a Teams assignment. So not everybody's a Microsoft school, but inside of Microsoft, you can track changes inside of that. Right. And so you can see when kids have added lots of stuff and when it's been modified. And I think that scares them to not cheat.
To know that that's watchable, yes. Yeah. Pretty much every platform has a similar kind of package like that.
Yeah.
Let's see, somebody else is asking, so your students are doing basically the 2 investigations your students are doing for the summative assessment. Was it their choice of choosing variables, or was it your choice as a department to say, you're going to do these?
Sure.
Yeah.
So I think the kids need to have a degree of choice, but led in the right direction so they don't totally stuff it up. So I think the task that we used is what's on the NZIP site, and it said suggested variables, ramp length, ramp height, surface. We gave the friction coefficients of the surfaces, so I actually went out there with my force meter and measured force versus weight force. They had to have some numbers so that they could be numerical, but they got to choose which of those was the easiest or more straightforward. And yeah, so leading them in the right direction, but not telling them this is the only answer. And they had to use their data and provide their data in their report, or attached to their report, which meant like you can't really cheat if you had to prove that this is your data set, and then you've had to analyze your own data set. Like it's really hard to then to cheat on that's quite difficult unless you steal somebody else's data set and report. So
Exactly. All right. And you mentioned that, you're just finishing this, so it's probably too early to ask this question. But a year from now, one, would you keep this as part of your package? And would changes manifest in what nature?
yeah. So this evening I went through a whole range of different, I don't know, summative like tasks you could do. I think when I was planning this at the end of last year, I'd kind of put energy in a different box, thinking, oh, that's what the external content is, and so therefore I can't cover energy. Therefore, it's got to be this more narrow mechanics, whatever flavor. I think I probably evolved in my thinking over there. I think end of last year, I was stressing that actually the only way you can get really good data is using motion sensors, and so I appreciate SLT for letting me spend some money to do that. And actually, in retrospect, they're really helpful. But with the right task, you could actually do it really, really well with a stopwatch.
Yeah. And those rubber bands, they're amazing. Yeah.
Yeah, and the rubber band stuff is really good. And so like I quite like the rubber band, the shooting car and the rubber band car. Like I think if you did that with a stopwatch, you could go onto the tennis court and you'd smash it. So
although I will warn you, you can't use old rubber bands. I've fallen into that trap. The age of a rubber band is one of your factors. And if it's over a year sitting on a shelf, you just go buy a new bag of rubber bands. Yeah. Save your trouble. They're cheap.
And brand and thickness and there's all those kind of factors. But so I probably would include more energy next year, I think. And like we want it to be fair to the other sciences and that holding it to a term. But we don't have anything planned for term 4 because we're not totally sure what's happening with this genetics, external, internal, whatever. And so maybe next year we'd do a real 11 weeks of each and carry into term 4. So that there's more time. We felt a little bit rushed, probably.
Yeah, the deadline to get that genetics thing I think is Labor Day, but nobody's going to push that envelope too hard on the first year.
Yeah. So it's all a bit of a learning curve in that space. But I think we'd probably do more energy. I'm overall pretty happy with the decisions that we made, and the experiments worked. The kids are happy with the formative and the summative. Actually, the blow kart, the land yacht was actually conceptually easier for the kids than the ramp. Kids have actually found the ramp quite hard. It's quite fascinating because there's 2 types of motion, and figuring out what's happening in each bit was actually conceptually quite difficult for a number of kids. And so I might not use that as I don't know. We'll have to see what they write.
True. You won't know until you finally get to the other side of it.
Yeah.
How many teaching staff are involved here? You said you had 8 or 9 classes.
There's 7.
So 7 teachers. How are you managing the cohesiveness of the staff thinking on what's important, what's not, the wording of, and you know what I'm saying? That crazy management of somebody in charge of that many staff on an internal.
Yeah. And when 3 of them are away on camp every consecutive week, Right?
Exactly. Yes.
We've had to have a lot of meetings. And there's been a lot of comms across, a lot of communication around expectations, and it's been healthy for staff to pull things apart and go, well, what does this mean here, or how does that work there? And then some staff have had some summary PowerPoints, or a number of conversations collectively and then in small groups. You need, whenever you're doing things new, if you want to be united, you're going to have lots of communication.
Very.
Cool.
Well, does anybody have any other questions? I'm sort of keeping an eye on the chat and letting James and I just, chat away here at the same time. Somebody put a nice link in the chat if anybody wants to dive into Amazon and the Pinewood Derby cars.
I mustn't be seeing the chat. Like my chat looks. No, I don't know. That's all right. You're reading them out well. My chat looks weird.
Yeah. Well, let's see. Any other big broad things like well, somebody's asking the how much of what you just presented is sitting inside NZIP's secure site?
Well, maybe I could show that now so people can get a sense of what I'm talking about. Oh no, did that send as a picture?
Well, no, you just put the bit.ly in there. Yeah, so in the chat is the bit.ly link, and
Yeah, so
that'll take people right to it. Yes. So Vanessa has exactly what she needs. Or not Vanessa, sorry, Roxanne. And here's a question for you while you're doing that. Did you develop a tick grid marking scheme for your Achieve Merit Excellence, or did you just go with the flow and then reverse engineer what's the merit threshold and what's the achieve threshold?
Yeah, so we spent quite a bit of time on marking grid. Yeah, how do I say this well? So I came up with what I thought was a good student matrix. I think if the kids know what they need to do, then they'll tell you what they need to do, right? Like they'll raise to that level. They need clarity. I put that to NZIP and the moderator, and they said that was too leading.
Okay, too leading, yes.
Which I think in reflection they were right, but the first year you're running through it, staff need that guidance.
Oh, totally.
And so, yeah, it's not in the NZIP material, unfortunately, but we
Well,
use that
it's like you said, the showing the kids how an excellence could be worded. You showed them, but you didn't let them write it down. So
Yeah.
it's that there's leading and there's spoon feeding, and there's somewhere in between is that sweet spot.
And so we had the student marking grid that we didn't give the kids. The kids had never seen it, but that led us to what minimum was that they needed to have a dependent independent graph times 2. They needed to have relationship. They needed to have physics linking times 2. They needed to have an overall connection. Yeah, they needed to have a speed calculation. So we'd gone quite fine nitty gritty on our expectation. But to the kids, they just saw, well, this is what the excellence kid wrote, so that's what I'll regurgitate.
Yeah. And like you said, you won't know until you probably in the early weeks of term 2, let's be honest. Mop up and you make all those final decisions on what are things worth and the outliers and the different interpretations that manifest.
Yeah. And I suppose we showed multiple examples of how you could do graphing or how you could do calculations. So lots of kids have done it quite abstract ways because we hadn't told them this is the cookie cutter approach. And I think staff have actually commented on how rich that is. That so often, like if you look at, I don't know, physics 2.1, there's a particular structure and there's an outcome and you're like, oh, okay, there's a relationship, but I don't really know what it means. We're here, the relationship's quite clear. It links to a real life something. Yeah, to make the land yacht go fast, I need to do this, and this is the reason why. Like, I think the physics is quite rich, which I think we've been reasonably surprised and happy with across 60, 70, 80% of the cohort.
Vanessa has asked another good question. I'm assuming she means during the assessment, but Vanessa, you can turn your microphone on and correct me if I'm wrong. But did the kids write up each investigation they completed in the build-up to the assessment, like the practice of writing up an assessment? The middle of term 1, let's say, or before you did the formative, did the kids have practice writing things up?
Not really, no. So in our booklet, there's one on the balloon cart, and we discussed that as a class, and they had to write the physics of that. And so that was kind of, we modeled aspects of it, but the formative was the first time they saw all the bits together.
Gotcha. And that was done what, like pretty much right before Easter?
Yeah.
Gotcha. Okay. Yeah, I was interpreting that correctly. Thanks, Vanessa. Anything else for James? You've been through a massive, build the plane as it flies, obviously. And so many people have also been trying to do that around New Zealand for the first time. Whether it might not be the physics internal, it might be one of the other flavors, but that's what's happening out there. Most schools didn't feel like they wanted to start term 1 with externally assessed material.
Yeah. I thought I'd show you what that bit.ly link takes you to if you haven't clicked it already. So there's a link to the PowerPoint that I went through. There's a link to the booklet that I showed. There's a link to that scheme of work. There's a link to the tasks that we've used at Middleton. I don't really want to show them on a recorded video, but if you're an NZIP member, you can log in and see them. There's some stuff on Central Hawke's Bay and some general tasks, SLOs. What's this one? There's a link to all the other videos that we've had on the other workshops, some Jonathan Jaffrey's prior NCA level 1 PowerPoints. There's a copy of the achievement standard, some exemplars. So all of that's just sitting there, and you should just be able to click into it. And if you ask you to log in, it's because it's behind the NZIP secure bit.
Cool.
Yeah. So if that's helpful.
No, it is. It's very helpful. Yeah. Alrighty. Well, any other last minute questions that people might have? Otherwise, we will let James probably finally get home from work before the doors get locked on you. The alarms get set. Doesn't look like it. Well, in that case, well, I'll thank everybody on your behalf. A few people are already thanking you in the chat that you can't see. And I'll stop the recording. And